Hello and welcome to a nostalgic chat with me. We are busy with IEB's May 2024 paper 2, and today we're looking at question 6b, which is a trig question. Let's get right into it. If sine of 17 times cos of 17 is equal to k, determine the following in terms of k. Okay. Fantastic. Right, so the first one is sine 34. Okay, and it does help to just kind of see that 17 is half of 34. So that kind of hints to me that we are, probably in the land of double angle identities. Another thing that could kind of hint that is, in as much as you don't have to memorize formulas, I've always found it helpful to memorize them because then you can spot that this relationship over here, or this particular product, sine A, cos A, it kind of looks like the identity that this is, if you put a little 2 in front of there, then it's the same as sine of 2A, right? Which again is, we're talking, this is 17, and 2 times 17 is 34. So, that again is like kind of already, just from seeing this, I'm like, okay, I think the useful thing to use here is double angle identity. So what is the moral of the story? The moral of the story is times tables are fantastic. If you didn't do times tables as a kid, I don't know if how effective it is to try and learn them when you're older. I'm sure it is. I would say like to know the times tables for 2, 3, 5. I think those are useful times tables to know. Anyway, and then secondly, like, it doesn't hurt to memorize formulas. Right, so we know that we've been told that sine 17 times cos of 17 is some number k, and of course you could calculate what it is. You could just could calculate what k is, and then kind of reverse engineer things. So what I mean is and they haven't said without a calculator for this question, so you really could use your calculator, I think, but that would not be the beautiful way to do this problem anyway. So k is this number 0,279596, right? Then if you calculate sine 34, you'll see that it's equal to 0,559192, and then you can try and figure out, okay, what's the relationship between these two numbers? So you could divide. I should have stored the answers actually. Anyway, fine. I'm going to divide it by k, which is sine of 17 times cos of 17, and we then see that sine 34 is twice k. So what did I say? Sine 34 is twice, this number. So then you could say sine 34 is equal to 2k. I don't know if that's an acceptable way to do the question. I think it is, if they haven't explicitly said, don't use a calculator. Anyway, let's do it the beautiful way. So we are trying to get from this to this, right? Kind of trying to see how we can manipulate this equation so that we get from here to here. So we do know that 2 sine 17 times cos 17 is equal to sine of 2 times 17, right? That's just the double angle identity for sine, and that would then be the same as 2k, right? So all I've done is I've times both these sides by 2, right, to get this and this. But we also know that this would be the same as this using the double angle identity. So in a nutshell, sine of 34 is the same as 2k, which is what our calculator also told us. Right, next one, 2 sine squared 17 degrees minus 1. So again, that for me screams the cosine double angle identity situation. I always get confused about which is which. So cos squared a minus sine squared a, well, okay, so cos 2a, this is just me refreshing my memory here, is equal to that. And then you can replace the cos squared a with 1 minus sine squared a. Okay, so, okay, in a nutshell, 1 minus 2 sine squared a is equal to cos 2a. So that's the one I'm going to use. That looks like it's the puzzle piece we need. Okay, so, and of course, this is also given to you in the formula sheet, so. But like I said, doesn't hurt to memorize some formulas. Anyway, so again, this kind of looks like this, except they're swapped around. So it's giving negative cos 2a is equal to, you know, this. So how will I get cos 34? How will I get to cos of 34 from here? Oh, unless if I do the diagram. Yep, I think I'm gonna need to do the, what do I say? What do I call it? So we have information. We know that sine of 34 is 2k, and we now want to figure out what is cos of 34. So let me actually just write that a bit more clearly, right? Because this over here has given me a direction to move towards. So pretty much I want to get an expression for cos of 34, because then I can figure out an expression for this guy. So if I'm not explaining it well, it's because I'm also not completely clear on what I'm trying to do myself. Okay, so we know that cos of 34 is equal to 1 minus 2 sine squared 17, right? And so therefore negative cos 34 is equal to this difference swapped around. Okay, so now I want to get an expression in terms of k for this guy. And because I already have an expression for sine 34 in terms of k, I can then use my little pretty diagram, right? So we know that 34 is in the first quadrant, 34 degrees. Okay, and what we have discovered is that the ratio y over r, right, sine 34 is 2k, or we can say 2k over 1, right? So then that means I don't know what my x coordinate is, but I can make my y coordinate 2k, and the length of my little radius arm there is 1. So now we can do some Pythag to figure out the x coordinate so that we can figure out cos of 34 in terms of k. So Pythagoras 2k squared plus someone else squared is equal to 1 squared, because Pyth said so, right? And so that is 4k squared plus my unknown squared is equal to 1. And so therefore this guy is the same as 1 minus 4k squared, and so question mark is going to be the positive square root of 1 minus 4k squared, because we are in the first quadrant, so we know that the x coordinate is positive. Okay, and so then we can say, right, we now know that this guy is in fact 1 minus 4k squared, well, the square root of that. Right, so therefore, cos of 34 in terms of k will be the square root of 1 minus 4k squared over 1, which is just the same as the square root of 1 minus 4k squared. Okay, and so to now find the negative cos 34, which will give us the value, well, the expression in terms of k of this guy. So minus cos 34 will be negative square root of 1 minus 4k squared. And so this then is the expression of 2 sine squared 17 minus 1. All right. And of course we can sanity check ourselves, right? So essentially what we're saying is that this number over here, if we calculate it, is going to be the same as if we take the negative square root of 1 minus 4k squared. And what is k again? K is this guy over here. So let's see. Let's see. Ooh. Okay, so first let's calculate. Hey, wait. 2 times sine 17 squared minus 1. That gives us a negative 0.829, blah, blah, blah. Right, and we are saying that this number will be the same as this guy. Okay, bearing in mind that k is simply sine 17 times cos 17. So sine 17 times cos 17. So I am going to, I don't need to store it really. It's stored in ants. So we shall just use ants. Right, so now if we calculate minus 1 minus 4 times ants squared, okay, we should get, we get negative 0.829037. So we're looking correct. So I guess then the problem with, if you had just simply tried to attack this question purely using calculator, for this one it was clear to see that sine 34 relative to the value of this, sine 34 was just double this. So then it was easy to deduce that this is the relationship. But you see now for this one, if you just typed this number into the calculator and you tried to figure out its relationship to this number, it wouldn't have been immediately obvious. So this is why it was still helpful to approach it a bit more algebra-y. Okay, I hope I made sense and I hope you had fun doing this question. I sure did. Let's wrap it up here and hey, let me not be so cocky and assume that I am so correct, because the memo has shocked me a number of times in life. Okay, right, so yes, me and the memo are in agreement. Approaches are pretty much the same, so happy days. Cool. Thank you for tuning in, and I'll catch you again another time, hopefully.